Okay, welcome everybody to the East Language Technology Center's webinar series. We are now getting close to the webinar series in this talk in May by Andre Martins, which I will introduce in a minute. I just wanted to let you know that we have a new addition to our webinar series next Tuesday at 10 a.m. We'll have the pleasure to have a seminar by Sampo Pisalo, who will be talking about another closely related topic to what Andre is going to present today, which is the Open EuroLLM initiative. And then in June, we'll have Mirela, and that will be the end for this course. So it's a real honor to introduce you to Andre Martins. He did his PhD in CMU and Lisbon, and is an associate professor of in the University of Lisbon. He's a very influential researcher, and I'm really happy that he accepted to give this webinar, not only because he has 2 ERCs, which is a sign of the great quality of his research, but also because he has received Best Paper Awards, and he has co-founded the well-known machine learning school in Lisbon, and he's also a fellow of the Ellis Society and co-director of the Ellis NLP program, as well as advisory group of EuroHPC, which I think gives you an idea of how strong is his research. So having said that, Andre, feel free to share the screen. And as we just mentioned, Andre needs to leave in 5 minutes before the hour. So just take into account that for the question time after his presentation. Okay, Andre, thank you. The floor is yours.
Thanks a lot for the nice words. Can you see my full screen right now?
Yep.
Okay, so great. Thanks for inviting me to this seminar. Today I'm going to talk about some projects and some things that we put together that have in common the fact that they all promote open and multilingual LLMs with a focus on European languages. So the work that I'm going to talk about is the work of several people, both from my academic group at the University of Lisbon and the research team at Unbevel. So this is an offsite that we did recently, which includes people from both groups. By the way, the name of our group is Sardine, and you can see that we had to very carefully pick the letters to get Sardine. For those who don't know, sardine is a very popular fish in Lisbon, especially at this time of the year. And we just picked this name for our group. So there's going to be 3 main pillars that I'm going to mention today. And I'm going to argue that they are all connected, and we should explore positive interactions between these 3 different pillars. So one is LLMs with a focus on multilinguality. The other one is machine translation, and finally quality estimation and evaluation. Okay. So let me start by reflecting a bit on how machine translation has evolved over the years and its connections with language technologies and NLP in general. So, I could go back more years in time, but let me just start with the attention mechanism, which to me was a very important innovation in deep learning architectures. It precedes the transformer. This was first used for machine translation to mimic the idea of alignments that already existed in IBM models in statistical MT. But it had the novelty that it's a component of neural networks that is differentiable, and it was a big success. So at the time this was proposed by the team at Mula in Montreal, they managed with much smaller models, use the inductive biases of this attention mechanism. They managed to outperform models that were much larger that did not have the attention mechanism. So another example is tokenization. These days, all language models split words into pieces. There's many different ways of doing that. The paper that first proposed by pair encoding was also focusing on MT as an application. So this is another example of something that started in MT and got propagated to other areas in NLP. Then, of course, the transformer. This is the architecture that is used right now. It's the state-of-the-art architecture for many different tasks, not just for language, but for vision. There's many multimodal versions of architecture that are based on transformers. but originally this was conceived for machine translation. And then other things, techniques like back translation that are useful to augment parallel data that is used in MT with monolingual data. This is current practice right now to use synthetic data to improve LLMs. And I could go on, large-scale training. This is also something that has happened in MT for a long time, and it's now the bread and butter when developing large models. So these are just a few examples where MT provided tools that influence the fields, but we also have the other direction, right? So, and right now, I think we are moving to a world where we are having fewer specialized systems and more systems that have general capabilities, which includes translation in addition to several other things, and combine all these different capabilities to become more powerful. So if you look, for example, at the latest WMT, the Conference of Machine Translation, where many systems are compared in their ability of doing translation, the best systems right now are all based on LLMs. Okay, so I'm going to come back to this topic. But we are already at the point where specialized MT is less powerful than using LLMs for translation. On the other hand, this opens a lot of new opportunities. Problems that were considered difficult in MT for a long time. For example, translating entire documents or books, handling terminology and so on. They can now be unlocked by using all the power of LLMs, using some smart prompting or some smart way to solve these problems. And finally, we also have more informative translation quality evaluation by using LLMs as judges. And I'm going also to give some examples of that. And this is also starting to become the state of the art in MT evaluation. So overall, we see that task-specific research is declining. This is not specific to machine translation, but we can see, for example, by looking at how many papers are in the machine translation track at ACL. It used to be one of the most popular tracks at ACL for many years, but now it's declining. And we also see that there is more interest among researchers and developers to develop models that combine knowledge and can solve multiple tasks for the reasons that I gave earlier. But we might be asking if this means that it's going to be one-way traffic from now on. Is translation just going to be a consumer of the advancements in LLMs or not? And my point in this talk is to say that MT research still has a special part to play, and I'm going to elaborate a little bit more on that. Okay, so the first aspect that I want to bring is that evaluation is a very important matter in MT. Not just in MT, but I'm focusing here specifically on MT. So for many years, decades, the BLA was the metric that everybody used to evaluate the quality of translation. But this is no longer useful because systems are already at a level for high resource languages. Things might be different for low resource languages, but for many languages, systems are already at a level where we cannot distinguish the best systems by looking at BLA. So we need to start looking at better metrics. For example, metrics that are obtained through models that can be trained on data. And we have examples of that with the COMET, which has been developed by Babel, BLERT, Metric X, developed at Google, but you have like many different choices of metrics that are being developed right now that are much better than BLA in terms of correlating with human judgments. And this, the advancements brought by these evaluation metrics allow us to get a better and more reliable assessment of real gains. We can better measure progress in the field. Okay, so there is this very famous quote. So I'm going to present the quote in a bit, but first, can you guess who is the person in this picture, or does anybody know? Okay, I cannot see the chat, so I'm guessing that's I don't have any answers. So this is Lord Kelvin, very famous physicist, and he said this sentence that when you cannot measure, when you can measure what you are speaking about and express it in numbers, this means that you know something about it. But if you cannot measure it, if you cannot express it in numbers, your knowledge is very limited. And I think this also reflects a lot of the situation where we are right now, not just in translation, but also in language models in general. So you cannot really do progress in science if you don't have the ability of measure how well we are doing, okay? And there's many different ways in which systems can game metrics, benchmarks, and so on. This is a discussion that happens every day, okay? So I'm going to talk a little bit about evaluation and some of the work that we have been doing in this space. The first thing I want to point out is that evaluation, to me, it's much more than just comparing systems. We are not doing evaluation just because you like leaderboards or because you want to compare what is the best system for each task. We can actually use evaluation in many more ways and ways that are much more interesting than that. We can use evaluation metrics, for example, for data filtering. If we have a good metric that reflects the quality of translation, then we can filter parallel data that might be noisy, right? So you can create a much higher quality data by taking a large piece of raw data, taking from the web or crawls in some way, and doing some filtering using the metric that we trust. The second point is alignment. So we can use evaluation metrics as reward models or preference models, as you prefer. And you can optimize MT systems or language models to produce outputs that tends to have a higher quality. And we can also use what we call quality-aware decoding, which means using these metrics at inference time. Okay, so we can develop decoding strategies that incorporate quality assessments on the fly as they are decoding. Okay, and I'm going to talk a little bit about that third aspect as well. And here, all these examples are interesting because even though now, this is relevant for LLMs in general, but MT pioneered research in these areas again. Okay, so regarding data filtering, this is something that the machine translation community has been doing for a long time, moving from to a paradigm where data quality is more important than quantity. Regarding model alignments, there is a lot of work, even before NeuroMT, on optimizing models according to automatic metrics. And regarding quality-aware decoding, so we see now that LLMs like the O series from OpenAI or DeepSeek models that are able to perform reasoning, they are now moving more to this test time scaling paradigm. Okay, but again, this work, a big part of it was pioneered in MT. So I'm going to describe our research path that touches some of these aspects. So I will start with COMET. So COMET is an evaluation metric that became very popular these days. It's the default metric, automatic metric that is used in WMT, the conference where we compare different machine translation systems. It's also widely used in industry. This is a family, it started to be a family of reference-based metrics. Reference-based here means that you judge the quality of a translation by comparing it to a reference translation. Okay, so we assume that there is a human written reference that you can compare against. And it really took off. Okay, so we can use COMET to track improvements in system quality. It's not a perfect metric, but there is, it's demonstrated through these different shared tasks and other experiments that we did in several papers that it has much higher correlations with human judgments than lexical-based metrics, which was used before. Okay, so after COMET, we combined that with work that we were doing on what is called quality estimation. By quality estimation, what I mean is not having access to a reference. So these are referenceless metrics. This means that you only get to compare a source text in one language with a translation produced by a system in another language, but you don't have a human reference that you can use to compare directly with your translation. So this is a lot more challenging. And we started to develop these referenceless versions of these metrics in tandem with the COMET reference-based metrics that I mentioned in the previous slide. Okay, and the reason why quality estimation is exciting is that if you have a system that is able to predict quality on the, without comparing to a reference, we can use it on the fly. we can plug it to an MT service and decide when this translation is good enough to be sent to people, or if it needs to be redirected, for example, to human translation for post-editing. Okay. Apart from that, we can do a lot of other things like a large-scale parallel corpora filtering, anomaly detection, and a lot of other things. Okay. So more recently, we evolved into what we called xCOMET. So xCOMET is something that we published last year. The X comes from explainable. By explainable here, take it with a grain of salt. We don't get like a lexical explanation about what the errors are, but we get some information about what are the words that are highlighted that might have errors. Okay, words that might be problematic. And this is useful because if you have a human translator that can look at that translation, it can fix the things that are highlighted, and this can increase the productivity of translators. Okay. So xCOMET, I'm going to describe it in the next slides, but it's a family of metrics of quality estimators that come in both versions, reference-based and reference-free. They are trained on data from WMT shared tasks, with as well as with some automatically generated data, and they allow extracting not just the quality score, but also error spans together with severities, which can be quite useful in practice. Okay, and these systems have been tested and compared to other metrics, and they demonstrated a strong correlation with human judgments according to WMT metrics shared tasks. Okay, so here's a quick explanation about what xCOMET is doing. In the input, you have the source and the reference. If you are sorry, we have the hypothesis. So the hypothesis is the output of the machine translation system, and then you can have three different things. You can have just the source. If you just have the hypothesis and the source, what we are doing is just quality estimation. So this is reference loss. But you can also have the hypothesis and the reference, in which case you are doing something reference-based. And even better, we can use both the source and the reference. So you can use this triple, hypothesis, source, and reference, which can guide you about where the hypothesis differs from the source, but also where it deviates from an existing reference. Okay, so the system is flexible, and you can use it either for reference-based or reference-less evaluation. So then we have a pretraining encoder. In the latest iteration, we used XLMR for this. We have a pooling layer, and then you have two heads. One head is outputting a score, a sentence level score. When I say sentence, think of it as paragraphs, because this works at paragraph level. But it doesn't output a score. It also outputs severity labels that are associated with the words in the hypothesis. Okay, so it tells you where the error spans are, and it comes with severity labels. For example, for this example, this will tell you that this part is associated with a critical error, this part is associated with a major error, and this again is associated with a critical error. Okay, so the good thing about marking error spans with severities is that there is one metric, a manual metric that is highly used in the industry called MQM. MQM stands for multidimensional quality metric, which is basically a formula on top of the number of critical errors and major errors and minor errors that might be in the translation hypothesis. Okay, so if you have these fine-grained outputs, we can actually map it to an estimated MQM score, which is what we can do with xCOMET. Okay. So, any questions so far? All right, so I will just proceed. So this is nice, but we wanted to do more than just evaluating quality. Okay, so the next thing that we thought about is, okay, if you have machine translation systems that are getting better and better, and you have quality estimation systems that are now working at a level that correlates well with human judgments, why don't we put the two together to improve machine translation systems in even more? Okay, this is what we call quality-aware decoding, right? Closing the loop and having this quality information being plugged to the system that generates the translation. Okay, So there are several ways of doing quality-aware decoding. There's two main ways for doing that. One is reranking. This is the simplest that you can think of. In the LLM world, people call this best of n. What this does is use your MT system to generate multiple candidates, for example, by sampling or by doing beam search and collecting the entire beam. And then we use a reference-less metric, a quality estimation system like COMET QE, to rank each of these candidates, and then you just choose the one that has the highest estimated quality. Okay, so this is a very simple approach. It tends to, we show that we can actually boost performance by doing that at the cost of spending a little bit more time doing inference, because now we need to deal with multiple candidates and we need to rate them. But it can be effective. The second way is minimum-based risk decoding, where what we do instead is we take all the candidates. Let's suppose we have 4. Typically, we have more than 4, but let's assume it's 4. We just compare all candidates with each other, okay, pretending that one of these candidates is a reference and the other candidate is an hypothesis, okay? And because we are comparing a reference with an hypothesis, now we can use a reference-based metric. xCOMET or COMET could be one example. And then what we do is we pick the candidate that seems to be the most, the one that is the most similar in terms of this metric with all the others. Okay, so what we are doing is basically maximizing the expected utility. So there is a connection with base risk. This is why we call this minimum base risk decoding. And it tends to perform a little bit better and in a more stable way than just re-ranking. Okay. Usually you need to do a bit more work because now you need to do a quadratic number of comparisons. You need to compare every reference with or every hypothesis against every other hypothesis, but this tends to pay off. And there's also ways to accelerate these comparisons. So we have this paper. This is a paper from NACL, I think 2023, where we analyze these things thoroughly. We compare these two strategies, re-ranking and MBR decoding, and we show benefits not just in terms of automatic metric evaluation, but also in terms of human evaluation. Okay, so humans agree that these techniques lead to outputs that have higher quality. We also looked at impacts in other things. For example, there is a big problem with the a problem that is quite relevant, especially when you are using high-risk content. For example, translating texts in the medical domain or legal domain, where even if very rarely systems hallucinate, when they do, this can have very high costs, right? So 0.1% hallucination rates might not be enough. We might need to lower it down even further. So we did a lot of work where we study hallucinations in the context of machine translation. These are a little bit different from hallucinations in facts from LLMs, right? So by hallucinations, we mean systems that detach from the source and they generate output that is unrelated with the source sentence. And we observed that by using this redundancy that is used in re-ranking and MBR, by leveraging the information coming from multiple samples, we can reduce reliably the hallucination rates. Okay, so if you want the details, you can take a look at this paper. We also looked at what happens if you are not dealing with specialized MT systems, but with LLMs that are doing translation. And we saw that the same techniques, re-ranking and MBR decoding, can be effective, both at reducing hallucinations and at improving the final quality. And both closed systems that rely on very large models, but also systems that are not that large. So more recently, we had this more theoretical analysis. This was a paper at NeurIPS 2024, last year, where we analyze this connection between these two components, the machine translation component, or more broadly, language generation component, if you want to talk about our LLMs, and combining that with a re-ranker, where we can plug a quality metric of our choice. How can we reduce the error in LLMs or MT systems by using the re-rankers? And we show a bunch of interesting properties that work even for imperfect re-rankers, which is the re-rankers that we have in practice, and also for generators where there is a statistical dependency between the different samples that they are generating. And this has a nice perspective in terms of communication theory that I don't have time to elaborate, but if you are curious, ask me later or check out this paper. Okay, so I covered most of these parts that are associated with quality. Now I'm going to switch to Tower, which is the LLM that we have been putting together. Is there any question about the first part before I move on?
Hi, can you hear me?
Yeah.
Just a short question. So when you're using a metric to improve the model's output, how do you make sure that you're not just learning or doing the gaming of the metric?
Yes. That's a very good question. That is a very good question. So there is, this risk of reward hacking or gaming the metric. So we need to be careful when we are doing, for example, MBR or re-ranking according to a metric. We should never use the same metric at test time. So you should use a different one. So, or even better, we should use human evaluation. What we did in our work was, for example, if you use COMET to do re-ranking or to do MBR decoding, then we use, for example, metric X, that is a different metric for evaluation, and complement that with human evaluation. So I should say that even using different metrics is not enough, because COMET and metric X are still highly correlated because they are trained on similar data. There's lots of data that accumulated over years in WMT that is used to train these systems. So correlations between these two metrics might still be problematic. And this is a very important issue that, I would say it's like an open topic of research. We recently put together, I forgot to put the link to that paper, but we put together a paper that tries to mitigate this metric interference. So we have this method called means. It stands for metric interference, where we, instead of using a metric to do re-ranking and then measure the performance with a related metric, we use a predictor that predicts the score of the metric as a surrogate. And this tends to alleviate significantly this issue of being too optimistic about the performance of your system. I would say it doesn't solve the problem completely, but it alleviates considerably. Yeah.
Okay, thank you.
Okay, so I'm going to move on to Tower. So we started to think about Tower at the end of 2023. And our vision at that time was LLMs at that time, they were very English-centric. They still are English-centric, but I think by now, even closed systems have much better representation of other languages than what they used to have back then in 2023. So at the time, it was really an important research problem to try to develop multilingual LLMs that have a better representation of other languages besides English. And in particularly, because you were very interested in machine translation, we wanted to develop LLMs that are good at what we call translation-related tasks. So this means not just MT, but also quality estimation, which I already described, or other tasks that are related at a pre-translation stage or a post-translation stage. Okay, so we focused on highly multilingual tasks that were not very well covered by LLMs at the time. Okay, and we started by focusing on 10 languages. We didn't consider low resource languages at this stage. I think that's, in my opinion, dealing with low resource translation is a completely different problem of its own. We didn't try to solve that. We focused on mostly high resource languages. We started with 10 languages. We expanded that later. And we considered a bunch of tasks, which includes pre-translation, for example, correcting the source, what we see at Unbabel, so Babel is a company that focuses on translation. We get a lot of documents to translate that contains lots of errors in the source. Okay, so there is a part that involves correcting the source before translating. Otherwise, you have this garbage in, garbage out problem. Or recognizing entities in the source, because you might have a special treatment for entities. Maybe you have like a dictionary or a glossary term or some guidelines that tell you how you should translate brand names or other kinds of entities. Then we also consider translation itself, both general translation, but also translating things that go beyond the scope of a sentence, for example, entire documents, or dealing with terminology terms. And finally, things that usually appear in the post-translation stage. For example, after you have the translation, maybe you can still tweak it by doing post-editing. You can also automate that by doing automatic post-editing or predicting error spans. This is what xCOMET does. Or ranking translations to decide which translation we are going to output in the end. Okay, so we consider several tasks that look like this, and we form the data sets that we call tower blocks for supervised fine-tuning or instruction tuning that focuses on these sort of tasks. Okay, this data set is public, right? So you can use it, and many other researchers are using that for developing their models. And so the tower recipe has 2 steps. Okay, so we start with the pre-trained model. Initially we used Llama 2. It was the best model, the best open model at the time. Then we also did the same on top of Mistral, then Gemma, later EuroLLM. Currently we're also working with Qwen. The recipe is very general. You can use whatever pre-trained model you want, which is good because models keep evolving. So it's good that you have flexibility about doing this on top of any model you want. And there are 2 steps. The first step is creating tower base, which we do by doing continued pre-training, right? So we collect a high quality data set that contains enough parallel data that puts the model in a good position to tackle multilingual tasks. And then the second step is instruction tuning or supervised fine tuning, where we call that, we lead the final model tower instructs, okay? And this one is optimized for translation related tasks, okay? So I'm going to summarize a little bit our results. There was a lot of engineering and a lot of experimentation involved in deciding what are the best data mixes for these 2 stages. But I'm going just to summarize here the results that we obtained in this first iteration that included only 10 languages. So we did experiments in WMT 23 datasets. This was done in the beginning of 2024, and we didn't get state-of-the-art performance at the time. So GPT-4 was better. GPT-4 was the best available closed model at this time, but we were very close. Okay, so we got performance that was statistically at the same level at GPT 3.5. This was ChatGPT. And better than other attempts. For example, ALMA uses like a similar framework, but without parallel data in the continued pre-training stage, and with a few other different design decisions. So we are clearly better than ALMA. We are also better than Mixtral, mixture of experts models. This is 8 experts with 7 billion parameters each. So even models that are quite large. Our tower instruct models with 7 billion and 13 billion were quite powerful. Okay, so this was encouraging. In this process, we released a lot of resources. I already mentioned tower blocks. You can check out the tower collection for data, for models. These 2 models that I mentioned so far are available. We also released evaluation results, and we also have a paper that describes everything in lots of detail. But we didn't stop there. So the next step was developing the second version of Tower with a lot of lessons that we learned when developing the first iteration. And we did several things. So we scaled up the model. So we did continued pre-training on top of models that are much larger than the ones that you consider in the first tower. And we also did a lot of work to improve the data that we used for the CPT stages and the supervised fine-tuning stages. Okay. So there's a few interesting findings in the way. One of them is that adding new languages does not cost you anything. So this means that you can have like a first version that supports a number of languages. We started with 10. If you want to add 5 more languages in the post-training stage, we can still do it without leading to catastrophic forgetting in the other languages. Okay, this is good news. The other thing is data filtering is really important. So what this is showing is for sentences of different sizes. So these are quantiles in source length, in number of tokens. We are showing how much we gain from the initial models that we had that were the 7 billion model, okay? And you know, this line is showing how much we improve just by using better data. And a lot of the gains are obtained just by improving the quality of the data. The second line is showing the improvements that we get if on top of that we also apply this recipe on top of a much larger model. So in this case, a 70 billion parameter model, which is 10 times bigger than the 7 billion parameter model that we are comparing against. And again, we can see a delta. It's not as big as the importance of the data, but it still gives you a considerable advantage. And so by doing this, we finally got the state-of-the-art results. Okay, so this is for English to X, so translating from English to other languages and averaging results. I'm showing here the 7 billion parameter model and the 70 billion parameter model, and we are comparing with the systems that were the best at the time, Sonnet 3.5 from Anthropic and GPT-4o from OpenAI. So we are tying here with the Claude Sonnet and outperforming GPT-4o. Okay. Right. So, by the way, this is using greedy decoding. Okay. So we are using, we are just doing one pass and getting the best token at each generation step. Okay. So later we introduced another, actually not later, at the same time, because we use this system to participate in the shared task. We combine this with quality-aware decoding. So we used MBR decoding, the technique that I mentioned earlier, using COMET as a judge, as the metric, and we got a big jump. Okay, so now we are clearly the best system according to xCOMET compared to all the other contenders. Again, take this with a grain of salt because we might be suffering here from reward hacking, basically the question that Amir asked a while ago, because we are not using exactly the same metric for MBR, but it's a related metric. I think here we used metric X for your ranking, and we are evaluating on xCOMET. So what we observed with human evaluation is that things are not as, the gains are not as big, but you still have very significant gains. Okay, so this is showing now with human evaluation. This is using a single quality metric. It's like a simplified version of MQM. We showed that there is a big improvement moving from greedy to MBR decoding according to manual evaluation by doing this. Okay. Overall, in the shared task where we had like many participating systems, and they also evaluated the performance of APIs like GPT-4, Gemini 1.5 Pro, Claude 3.5 Sonnet, and so on. According to automatic evaluation, Tower was the best system in all 11 language pairs. According to human evaluation, it didn't win all, and I think this might be because of the reward hacking that I was mentioning earlier, but it wins in 8 out of 11 language pairs, which is a very strong result. Okay. Right. So overall, we see consistently better performance from Tower compared to GPT-4 and Gemini 1.5 Pro, and the same performance with Claude 3.5 Sonnets. We don't know the size of these models, but we believe that these models are much bigger than Tower, even the 70 billion parameter model. So because of these successes, we also deployed this as a product at Unbabel. You should try it out. This is called widen.ai. If you scan these QR codes, or if you just type widen.ai in our browser, this will take you to a page where we can translate, similarly to Google Translate or DeepL. There is one piece of novelty. You can also add instructions to customize your translation. For example, you can ask, okay, translate me this in informal style, or translate this to an audience that is teenagers, and you might see text with a lot of emojis and stuff like that. So this adds like information to the system prompt that you can leverage to obtain a translation that is more suitable according to your needs. Okay, take a look at widen.ai if you want to try it out. Okay, so there's a few other things that I don't have time to detail, but we also looked at MT specific alignments. So in Tower, in everything that I mentioned so far, we do continue pre-training, we do instruction tuning, but we don't do anything like RLHF or DPO, right? But we experimented with that later on, and we saw some gains as well. Okay, the gains are not as big as the ones that you usually get when you are applying the same techniques with LLMs, but if you do carefully this work, and if you pay special attention to the quality of your preference data, then you can further boost the performance of your model. And one thing that I find particularly interesting is trying to do this alignment at test time. So, for example, we had this paper at NeurIPS last year called Quests. This is basically using these quality metrics to sample at test time for machine translation. Okay, so in this case, we are sampling from the Gibbs distribution that is induced by your reward model, as opposed to sampling according to the MT system or the LLM directly. And this can further give you samples that are diverse and very high quality. There is also work that we did on interpretability, work that combines these components in different ways. For example, xTower, it's a tool that you can use to translate, find errors, refine the translations, and so on. And we also looked at when you use LLM-based MT systems, where in the context, how is the context influencing the words that you are generating? And we got some surprising results from this work as well. Okay, so I think I will need to wrap up a bit. My point again is that I think MT research has a lot to offer to LLM research. We saw this example with some of the things that I mentioned so far. Tower is a direct product and reflection on the dynamics of MT. But we are still a bit unhappy with this dependency on a backbone LLM. Okay, so what we really wanted is to have state-of-the-art MT systems or even models that have general capabilities for MT-related tasks, but that do not depend on an external model that we cannot control, right? So, for example, we have many open weights models, but we don't have any control about which data was used to train those models, right? So this is still a bit unsatisfying. So we really wanted to train a model from scratch, and this led to the EuroLLM projects. You can take a look at EuroLLM.io for more details. This is an European collaborative effort. It started in 2024 as part of the other projects with a collaboration with the Centrale Supélec in Paris. The goal here was to develop the best open European LLMs. We wanted to support all the official EU languages, plus some additional languages. Basque is still not there, but we really want to add it there in future editions. We committed to release 3 model sizes. 1.7 billion, this is done. It was released last October. And 9 billion, a 9 billion model, this is already completed as well. We released it in December last year, if I'm not mistaken. And we are still in progress of training the 22 billion model that we expect to be finished, in 1 or 2 months. And so far, these models have been quite impactful. So we got, more than 200K downloads of our models in Hugging Face up to February this year. Okay. Of course, you need a lot of compute to do this. So this is not the kind of thing that we can run on local clusters. So we benefited from an extreme scale grant at EuroHPC. This is the European Supercomputing Infrastructure. So this is running in the Mare Nostrum 5 in the Barcelona Supercomputing Center. And the total is around 1.7 GPU hours, 1.7 million GPU hours. So I think I will wrap up a bit because in the interest of time, but we designed our tokenizer to be a little bit more friendly to languages that are not English, so that if someone sells these models, you pay less per words. If you are using data that is not English, we also use the learning rate scheduler that was not this cosine scheduler, which most people use, but rather this trapezoid scheduler, where during the pre-training, most of the time you use the fixed learning rates, The reason why this is nice is that you produce a lot of checkpoints along the way, and you don't need to know beforehand what is going to be the size of the pre-training data. So this will make it easier to continue the pre-training of our LLM models later on if you have more compute in a different cluster, okay? Which is actually something that we're planning to do. So we have two phases in training. The first phase uses 90% of the data, 3.6 trillion tokens. The last phase, we call it annealing, uses 400 billion tokens. And we carefully choose the data mixes in both phases. Okay, so the data comes from web crawl data that is filtered and deduplicated in many different ways. We focus on high quality data coming from Wikipedia, from archive, from books. We use a lot of parallel data, and this is also why the model is so strong in translation related tasks. We use a lot of AI filters, COMET QB combined with other AI filters that we developed on purpose for data creation. And we also use code and math data because there's plenty of evidence that this improves the capabilities of models to address more complex questions. So we, the model still uses a lot of data for English. 50% of the data is English, but this 50% is much less than what we see in many other models that are provided openly. Okay, so in the initial versions of Llama, what they reported was something close to 80% English or something like that. So it has overall much better representativity of other European languages. And for the annealing stage, we are even more, we try to have even better representation of the other languages. Of course, for languages that are very low resource, they end up not having a lot of data, but we try to use the highest quality data we can. Okay, so wrapping up, so these are evaluations that were done for the 9 billion version model, the biggest model that we released so far. And we are comparing here with the strongest models of the times. This is outdated by now because you have new models coming out every week. So now there is already Gemma 3 and Qwen 3, but here we are comparing with Gemma 2, Qwen 2.5, Llama 3.1, and so on and so forth. And we obtain very good performance in multilingual benchmarks. Okay, so I'm showing here ArcSI, LSWAG, MMLU Pro, and MUSR. You are comparing, so everything that is outside these red boxes are models that are developed outside Europe, by Google, by Alibaba, Meta, IBM, Cohere, and so on. The ones that are inside the box are models that are made in Europe. This includes Mistral. It also includes models that are developed in initiatives that are similar to EuroLLM, like Salamandra, that is developed by BSC, and Oxyglot, that is developed by a consortium in Germany. And EuroLLM is among those models, the one that is strongest. We also tried in MT benchmarks, where, unsurprisingly, our model gets very good performance. And this comes mostly from the fact that we were very careful in terms of the parallel data and the filtering that we apply to this model, to these models. And here we see that our model is even better, or at least competitive with the best international models like Gemma 2, 9 billion, and so on. So if you want to try out EuroLLM, I don't have time to show examples here, but you can take a look at this link. I can send you that information later on as well, and you can play a little bit with it. And it's not perfect, but I would say for its size, it's quite good. So next steps, we are finalizing the training of the 22 billion parameter model. We are also developing new capabilities of these models. We are training an MOE version of EuroLLM. It should be out soon. We have another grant in Leonardo in the context of AI Boost grants, where we're using 2 million GPU hours to do the MOEification of this model. We're also building multimodal models that add vision and speech encoders. And we're also working to get reasoning capabilities in these models and a few other things. Okay, so this is all I have. I still have 3 minutes for questions, and then I need to run. Thanks, everyone.
Thank you, Andre. Thanks for a great talk. So sorry, we just have a couple of 3 minutes. So for questions, because I know you have to rush. Let me make one question, is that you mentioned at least in the tower work, that you were using other backbone LLMs, which is the thing that you start to try to get rid of in EuroLLM. Do you have an impression, or do you have data showing what is the impact of the backbone LLM? I mean, because you do post-training or fine-tuning, which is based on MT and then evaluate on MT, it might be that the quality of the backbone is not so important after all, right? Do you have any intuitions on that?
This is a very good question. So, it has an impact. For example, the first experiment that we did was to train a 7B model first with Llama 3 and then with Mistral, and the Mistral version is much better. So both versions are actually available. So you can also try it out and see what are the differences in other downstream tasks. But I would say that the influence of the pre-trained model can be quite significant, just because if we start with a better model, the most challenging translations, they involve a little bit more knowledge and just the ability of doing translation. But what we are noticing now is that the models that are coming out, for example, models coming from the GMA series, they are much more multilingual than they used to be 1 year ago. So I think the importance of the CPT, the continued pre-training that we're doing, is going to become smaller over time. So you might need to have smarter ways of doing continued pre-training, or not focusing exclusively on multilinguality, but on other properties as well that are not yet captured by the models that are coming out. But yeah, this is a very good question.
Thank you. Maybe we have time for one question. I will read the first one in the chat. And I'm afraid we don't have time for more questions. And the first one in the chat was whether you could elaborate on what you mean by improving the data. I think this was in the tower. Yeah.
Yeah. So I would say it was mostly different cleaning techniques. We had some synthetic data that was quite helpful. We did that in the second version of Tower. In the first version, we didn't have that. But I would say that the way you clean the data is very important. But cleaning is not just running like a basic filter. It's really training a model to filter the data. That makes, if you look at things like FineWeb-Edu, for example, from Hugging Face, having something that does something similar at the multilingual level can be quite impactful. So we basically did that. We are going to release this information, this data and the filter soon, so that other people in the community can use it as well.
So was this referring to parallel data alone, or was this also referring to monolingual data in several languages?
Monolingual as well, yeah. So we used filters in both. For parallel data, we used COMET like filters because they're quite powerful for parallel data. For the monolingual data, we used something more similar to FineWeb-Edu.
Mm-hmm. Okay, it's 5 minutes to the hour. Maybe one last question, or you really need to rush?
No, one more is fine.
Okay. So next question was from, sorry, I forgot to say that the first one was from Ana Axenova. The next one is from Enrique Lopez Cardoso, and he asked whether EuroLLM outperforms Tower for certain European language pairs.
That is a very good question. So the comparison here should be the 9B version of EuroLLM with a tower of the same size, because if you look at the largest tower just, by the benefits of scale is better than EuroLLM. For machine translation, Tower is better because Tower was specifically designed to be strong at MT, but EuroLLM is also quite good, for a model of that form, of that size in MT. So in general tasks, EuroLLM sometimes is better, but Tower, again, I see Tower more as a recipe that you can apply on top of another model and not as a closed model. So if you're talking about initial towers, then yes, EuroLLM is better than those initial towers that are publicly available. If you talk about the most recent towers that we are building, then now we have better towers and EuroLLM needs to catch up. And one thing that we need to do with EuroLLM is also to do longer training, because EuroLLM was trained on 4 trillion tokens, but if you look, for example, at Qwen models, and Qwen is a very strong model, they use a lot more pre-training data. So we need to catch up on those things with EuroLLM in order to keep having models that are competitive.
Okay, so I see that you have to leave. Thank you very much, Andre. I think there are other questions on the table. Myself, I would love to make you more questions, but thanks again for this.
So sorry that I have to rush, but feel free to send those questions by email and I can answer them offline.
Okay, thank you, Andre.
All right, bye-bye.
Thank you. Bye-bye. So to finish the day, I think many people here started to rush off, but remember that next Tuesday at 10 a.m. we'll have another seminar which will be announced tomorrow, where Sampo Pisalo from Finland will present another closely related project to EuroLLM, which is a project called Open EuroLLM, which just started to work on Tuesday. So anybody interested in European LLMs, that would be, I think, a nice talk that you can attend in the webinar. And as I said, it will be announced tomorrow. So you'll receive news about it, so you can sign it. Okay, thank you everyone for attending to this webinar. Bye.